Hey guys, it's Miss Lane. So last week you took a quiz on triangle centers. This week we're going to talk about triangle inequality. These notes match up with the blank guided notes that I posted on Google Classroom. So you can either take these notes in your notebook or you can print out that blank sheet and fill it out as we go. I did not use all of the examples on the note sheet in this slideshow, so you can complete those for extra practice. And your assignment at the end of this lesson is going to be posted on Google Classroom as well. In this video, you have a lot of freedom. You can pause the video wherever you want if you need time to finish copying the notes, or you can pause the video before I complete a problem so you can try it on your own. You can also mute this video if you don't want to listen to me. Not very advisable, but the ball is in your court, so whatever you want to do. So today we're going to talk about triangle inequality. This is the last lesson that we're going over in this unit, so it's the first part of the last lesson. Triangle inequality. We have a theorem that goes along with triangle inequality, which is called the triangle inequality theorem. The triangle inequality theorem tells us that a triangle exists if the sum of the two smaller sides is larger than the third side. So very important for this. We're trying to identify the two smaller sides of our triangle and making sure that the sum of those sides is larger than the third side. And remember, a little review, inequality symbols. We have four inequality symbols. Greater than looks like this. Greater than or equal to has the line beneath. Less than looks like this, and less than or equal to. Those are our four inequality signs. The only one that we're going to be using today is greater than, because that's the one that matches up with our theorem. So our first example, is it a triangle? To determine if it's a triangle, we're going to identify our two smaller sides always. That's from the theorem. So for number one, we have sides 8, 17, and 24. The two smaller sides are 8 and 17. If it is a triangle, then the sum of our smaller sides should be larger than the third side. So let's check. To check, we're going to do 8 plus 17. That's the sum of our two smaller sides. Must be larger than, so we're going to use the greater than symbol. And the largest side of our triangle is 24. So you always want to have the largest side of your triangle all the way on the right side of your inequality. When we simplify, 8 plus 17 gives us 25. 25 is greater than 24. So these numbers form a triangle. So this one is a triangle. For our second example, we have sides 3, 3, and 7. The smaller sides of our triangle are 3 and 3. So we have to see, is 3 plus 3 greater than the largest side, which is 7? If we simplify, 3 plus 3 gives us 6. 6 is not greater than 7. This is not true, so this is not a triangle. For number 3, slight typo here, the first number should be 25. So we have three sides of our triangle, 25, 35, and 12. And notice that these numbers are not in numerical order, so you can't always just pick your first two numbers and add them together. The two smaller sides of our triangle are 25 and 12. We have to make sure that those are greater than the larger side in order for this to be a triangle. So our inequality is going to be 12 plus 25 is greater than 35. 12 plus 25 gives us 37. 37 is greater than 35, so this is a triangle. And number 4, we have three side lengths, 24, 12, and 11. Our smaller sides are 12 and 11, so our inequality is going to be 12 plus 11 must be greater than 24 for this to form a triangle. When we simplify, 12 plus 11 gives us 23. 23 is not greater than 24, so these three side lengths do not form a triangle. So if you're given three side lengths and you're asked whether or not they form a triangle, you just have to set up an inequality using the sum of the smaller sides and making sure that it's larger than the third side. You're also able to find a third side range. So you can find a range of values that your third side can be equal to. And in this case, we're going to let x equal the third side. The inequality that we're going to use for this is A is less than X, which is less than B. So we're always going to use this equality for finding the range of the third side. And in this case, A represents the difference of our sides. So that's subtraction. And B represents the sum of our two sides. So that's addition. So we're always using this inequality when we're finding the range of the third side. So for number 1, we're given two sides, 14 and 22. We want to plug this into A is less than X, which is less than B. A is the difference. So we're going to do 22 minus 14. That gives us 8. 8 has to be less than X, which is less than the sum. So 14 plus 22 gives us 36. So the range for the third side of this triangle, X can be greater than 8 or it can be less than 36. So any number within that range works for the third side of our triangle. For number 2, we're going to do the same thing. Our number all the way to the left of the inequality is the difference. So we have two sides, 31 and 28. 31 minus 28 gives us 3, is less than X, which is less than the sum. 31 plus 28 is 59. So the range of X values is X is greater than 3 but less than 59. For number 3, our side lengths are 3 and 11. So the number all the way to the left is the difference. 11 minus 3 is 8, is less than X, which is less than 11 plus 3 is 14. And finally, number 4, we have side lengths 19 and 45. 45 minus 19 gives us 26, is less than X, which is less than 45 plus 19 is 64. So anytime you're trying to find the range of values that can work for the third side, the number all the way on the left is going to be the difference, and the number all the way on the right is going to be the sum. And we can use this inequality to complete this next example. So if a triangle has lengths of 15 feet and 27 feet, circle all the possible lengths for the third side. So we're given two sides of our triangle. In order to figure out which of these lengths work, we're going to have to figure out the range again. So remember, we're using that inequality. A is less than X, which is less than B, where A represents the difference or subtraction, B represents the sum or addition. So our two sides are 15 and 27, which means our A value is going to be 27 minus 15, which is 12, is less than X, which is less than 27 plus 15, so 42. So any numbers in this list that fall between 12 and 42 are possibilities for the third side. So 34 is definitely a possibility. It is greater than 12 but less than 42. 12 is not going to work because this part of our inequality tells us that X has to be greater than 12. It cannot be equal to 12. 29 works because it falls in between this range. 18 works also, but 43 does not work because it's greater than 42. So these three answers are the only three that are possible to work for our third side. Another example similar to this, if you want to pause the video and give this a try on your own. If not, we'll keep going. So if a triangle has lengths of 45 centimeters and 9 centimeters, circle all the possible lengths for the third side. So again, we're trying to figure out that range of values for our third side, and then we're going to pick lengths from this list that work. So our inequality is A is less than X, which is less than B. A represents the subtraction, B represents the addition. So the two sides that we're given are 45 centimeters and 9 centimeters. 45 minus 9 gives us 36, is less than X, which is less than 45 plus 9 is 54. So the only values that are going to work for our third side have to be in between 36, and 54. 35 does not work because it's less than 36. 58 does not work because it's greater than 54. 47 does work because it's in between our values. 54 again does not work because this part of our inequality tells us that x has to be less than 54. It cannot be equal to 54. And 39 also works because it's greater than 36 but less than 54. So these are the only two options that work for our third side based on that range. With inequalities in our triangle, we're also able to order the angles of our triangle. We know that the angles of a triangle can be put in order by comparing the sides. So there are a couple of rules for this. The smallest angle of a triangle is always opposite the shortest side. I think we talked about this a little bit before the midterm, but the measure of an angle determines the length of your side. So the smaller the angle is, the shorter the opposite side. And the largest angle is always opposite the longest side. So looking at this diagram to the right, we can order the angles from least to greatest. Because we're starting with the least, then we want to find the smallest side because we know the smallest angle is always opposite the shortest side. So the shortest side of this triangle is 7 feet. That's side BC. The opposite angle is going to be the smallest angle. So the smallest angle is angle A. Then we're going in numerical order. The next smallest side is 10 feet. That opposite angle is angle C. And then finally, the longest side is 13, which means the largest angle is angle B. So from least to greatest, it's angle angle A, then angle C, and then angle B. We can do the same thing in the opposite direction. We're able to order sides. The sides of a triangle can be put in order by comparing the angles. So now it's just the opposite. The shortest side is always opposite the smallest angle. And the longest side is always opposite the largest angle. So looking at this diagram below, we're able to order the sides from least to greatest. Well, we're given two angles of our triangle, but right now we don't know angle F. We're able to figure out angle F by adding together 103 plus 42. That's going to give us 145 degrees. To figure out angle F, we do 180 minus 145, which gives us 35 degrees. So angle F is going to be, get rid of this question mark because now we know that it is 35 degrees. So now that we have all three angles of our triangle, we're able to order the sides from least to greatest. So least to greatest, we're starting with the smallest angle. The smallest angle here is 35, angle F. Opposite angle F is side DE. So DE has to be the shortest side based off of the angles. The second smallest angle is angle E. Opposite side is DF. DF. And finally, the longest side is opposite the largest angle, which is angle D. The opposite side is EF. So from least to greatest, the sides of this triangle are DE, DF, and EF. So let's look at two examples, and then you're going to be on your own for the practice problems. First example, order the angles from greatest to least. So now we're going from greatest to least, which means we're looking for the longest side first. In this triangle, we have sides 8 kilometers, 9 kilometers, and 11 kilometers. The longest side is 11 kilometers, which means the largest angle is angle C. The second longest side is side CD, 9 kilometers, which means the second biggest angle is angle B. And the shortest side is CB, 8 kilometers, which means the smallest angle is angle D. The last example is ordering the sides from greatest to least. So now we're ordering from greatest to least, so we're looking for the largest angle first. In this example, we're given two angles of our triangle. We always know the three angles of a triangle have to add up to 180 degrees. So we can find angle E by doing 180 minus 44 plus 90. That's going to give us angle E is 46 degrees. So angle E is 46 degrees. Now that we have all three angles, we're able to order the sides. So greatest, our largest angle is angle D with 90 degrees. The opposite side is side BE. So side BE has to be the longest side of our triangle. The second largest angle, but not by much, is angle E. The opposite side is side BD. And the smallest angle of our triangle is angle B, which means that the smallest side is side DE. So from greatest to least, the largest side is BE, the middle side is BD, and the shortest side is side DE. So that's for inequalities. Given one triangle, you can figure out whether or not it's a triangle, create a range of values for your third side, and order the sides and angles from least to greatest. That's it for today. Your assignment for today is posted in Google Classroom. That assignment is going to be due tomorrow, Tuesday, at 11:59 p.m. On Wednesday, we're going to continue on with this section.